Hi everyone. In this side exercise, we are going to work all the way through a blood gas interpretation. We'll be building on the exercise that some of you may have done of just doing the first couple of steps to kind of cut your teeth on all of this. So now, instead of having some of these steps grayed out completely or partly, we're going to do all of the steps through to the end. Remember last time we used a simpler version of the quadrants, just explaining the primary alteration and expected compensation in each quadrant. This time we're going to go further in terms of determining, if appropriate, the acuteness or chronicity of what's going on, and then thinking about whether or not we have the expected compensation. So I'm going to choose this first case to work through all the way. I'm putting the blood gas up in the upper left corner, similar to what we did previously. And let's start working it. First of all, acidemia or alkalemia? Well, we've got a pH that is 7.20. So that's pretty dramatically decreased. That means that we have an acidemia. So we're in this side of the quadrants. All right, next step. What is the primary process? Well, we have an increase in CO2 and we have an increase in bicarb. You can approach this a couple ways. You can pick one randomly and think about where it goes in the quadrant. Another approach would be to say, well, PCO2 is my volatile acid, and bicarb is my base. Which one of these in greater quantity would cause a tendency towards acidemia? So adding acid makes acidemia. Adding bicarb is an acidosis process, and we are going to be suspicious that that is compensatory and not primary. So either way, you're going to get to this pairing, increased PCO2 and increased bicarb. Now, just to explore points of possible confusion, where else do we see increased bicarb and increased PCO2? Why isn't it over here? Well, we don't have an alkalemia. We have an acidemia. So we're not going to get confused by that. Now, the next step is, since we are in the respiratory row, we need to decide how the kidney has responded to a respiratory perturbation. Particularly, what I'm saying is this an acute phase or a chronic phase of compensation? So now we need to look at the change in PCO2, and some people call these change of PCO2 of 10 of dimes when they're doing these calculations, but what we have here is a change of 30 from normal, right? Because 70 minus the normal 40 equals 30. Okay, so given that, we have 3 times the change that we would expect for a change of 10. So if this is acute, we would expect a pH change of 3 times 0.08, it's going to be 0.24. And if normal is 7.40 and we subtract 7.24, that gets about 7.16. So that's not exactly what we have. Let's take a look at chronic. 3 times 0.04 is 0.12, and 7.40 minus 0.12 equals 7.28. Neither of these is exactly right. What are we going to do? What I want you to do is to allow the same range of pH for your predicted abnormal as you do for your expected normal. This isn't quite right because, again, pH is not a linear function, but it will do, and we're not going to ambush you on the test with something like this. So if we say 7.16 gives us an expected range of something like 7.11 to 7.21, same range as the 7.35 to 7.45 normal. And here we're saying, well, we got a calculation of 7.28, but we should really be looking at 7.23 to 7.33. Then it looks like our winner is the acute change. So if this is in fact acute, let me get rid of a little bit of my drawing here. So if this is in fact acute, then for every change in 10, we expect a change in 1 of our bicarb. So 1 times 3 is probably going to be 3 in most of the world. So let's try that on for size. If normal bicarb again is 22 to 26, and we're gonna add 3, that's going to give a range of 25 to 29, and we're sitting at 28. So that seems about right. So at the end of the day, what do we say about this particular situation? Remembering that we have a pH of 7.20, a PCO2 of 70, and a bicarb of 28. We determined that this is acidemia, that the primary process is respiratory, that this is acute, and that the compensation is as expected. So putting it together, we have an acute, respiratory, acidemia with expected or appropriate compensation. Okay, I think that you are ready for the problem sets. Why don't you have a go at them?